In Lesson 10.6, we're looking at secants, tangents, and angle measures. You'll learn how to find the measures of angles formed by the intersecting on or inside a circle, and find measures of angles formed by lines intersecting outside the circle. How is a rainbow formed by segments of a circle? Droplets of water in the air refract or bend sunlight as it passes through them, creating a rainbow. The various angles of refraction result in an arch of colors. In the figure, sunlight from point S enters the raindrop at B and is bent. The light proceeds to the back of the raindrop and is reflected at C to leave the raindrop at point D, heading back to Earth. The angle F represents the measure of how the resulting ray of light deviates from its original path. A line that intersects a circle in exactly 2 points is called a secant. In the figure above, segment SF and segment EF are segments of the circle, or secants of the circle. When two secants intersect inside a circle, the angles formed are related to the arcs they intercept. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So in this, we've got measure of angle 1 equals 1/2 the sum of AC plus BD, where the measure of angle 2 equals 1/2 the sum of arc AD and arc BC. Find the measure of angle 4. The measure of arc FG is 88, and the measure of arc EH is 76. Well, this is really set up to find angle 3 first. So the measure of angle 3 equals 1/2 the sum of the two arcs that they gave us, so 76 plus 88. So what is 76 plus 88? 164, and half of 164 is 82. And so the angle we're really interested in was measure of angle 4 is the supplement of that. So 180 minus 82 equals 98 degrees. That's an ugly 8. 98 degrees. A secant can also intersect a tangent at the point of tangency. Angle ABC intercepts arc BC, and angle DBC intercepts arc BEC. Each angle formed has a measure half of the arc it intersects. So that is stated in Theorem 1013. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Find the measure of angle RPS if the measure of arc PT is 114 and the measure of arc at TS is 136. Well, so that whole major arc would be 114 plus 136, which is 250. So to get our minor arc that we're interested in there, PS, we need to take 360 minus 250 is 110. So now to get our, it's kind of an inscribed angle, I'm going to take 1/2 of 110 is 55 degrees. Secants and tangents can also meet outside a circle. The measure of an angle formed also involves half the measures of the arcs they intercept. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So to get the positive difference, I like to just call one of these, the big one, A, and the small one, B, because then we can always say x equals A minus B divided by 2, and that works for every one of these diagrams. So if you get a negative, it means you subtracted small minus big, but otherwise, if you subtract big minus small divided by 2, that is our formula every time. The book had a tip on absolute value for that. They said the measure of each angle A can also be expressed as 1/2 the absolute value of the difference of the arc measures. In this way, the order of the arc of the measures does not affect the outcome of the calculation. I don't think it's too difficult to subtract big minus small myself. Okay, so in example 3, our big angle is 141. Our smaller angle is O. Arc is x divided by 2 equals 62. So to undo divide by 2, we're going to multiply both sides of the equation by 2. So I have 141 minus x equals 124. And when I subtract 141 from both sides, I'm going to get a negative. Oh no. That's okay, divide both sides by -1, and x is going to be 17. And that one didn't need a degree symbol because you can see the degree symbol is already labeled on the x. A jeweler wants to craft a pendant with the shape shown. Use the figure to determine the measure of the arc at the bottom of the pendant. Well, if we let the value that we're looking for be x, then we know all the way around the circle is 360, so this is going to be 360 minus x. So altogether, those add up to 360. So now I can do my big angle, or arc, which I label as x, minus my small one. And I need those parentheses, because I need to be subtracting my negative x too. Divided by 2 equals 40. So again, to undo divide by 2, we can multiply by 2. Goodbye. So x minus negative x is going to be 2x minus 360 equals 80. Add 360 to both sides. 2x equals 440. And divide by 2. And x is 220 degrees. It's a little bit different, starting with only one value, but we knew what else to add. Nice simple directions again. Find x. Okay, we're using our big arc, just 6x, minus small arc, which is 40, divided by 2 equals 55, rule that we kind of established this lesson. We multiply both sides by 2. Times 2 divided by 2 cancels out. So I have 6x minus 40 equals 110. Add 40. Got some nice basic algebra this lesson. So 6x is 150. Divide by 6. And x equals 25. And again, I don't need the degree sign because it's already there. The measure of an angle formed by two secant lines is half the positive difference of its intercepted arcs, and the measure of the angle formed by a secant and tangent line is half the intercepted arcs.